talk about an actual sum that explains how a binomial distribution works. Now let's scroll down here. So this is the sum. Now the first thing that we have to remember about a sum regarding binomial distribution is that it has to be the probability will be given. So the percentage, whenever you see percentage, it is probably a binomial distribution. So that's a trick. And another information would be given is the number of trials. After all, the binomial distribution, we have both n and p. So here we have another number. Even without understanding the question, you can actually figure out whether it's a binomial or Poisson. In Poisson it would be on an average words, you will see that. So we know in a binomial distribution, the first thing we have to do is define the random variable, which is number of successes. So the first thing we have to do is define the random variable, and after that you have to define the distribution, the binomial distribution, and then you find the probability. So here let's start with the sum. So the sum is, before starting it, we have an idea that 30%, something is 30%. So what is 30%? The sales staff at an insurance company make house calls to prospective clients. Past records show that 30% of the people visited will take out a new policy with the company. So the success is 30% people buy a policy. So the random variable is going to be number of successes. So success here is people buying a policy. So number of people buying a policy. Okay, so the distribution would be defined as NP. So N is 8 people, and P is 0.3. 30% means 30 divided by 100, that is 0.3. Now let's start the sum. The sum is exactly 2 people buy out the policy. Exactly means equal. So X equals to 2. So how do you find it? Now again we have to use a table. Now let's look at a table. This is what the binomial distribution table look like. A binomial distribution table has first one block, which is n, the number of trial. So if you're looking for n, this is the block we're looking for. So this block here, so if n equals to 8, so we are talking about this block. So this is the block we are talking about. Now the next thing is p. So the value of p here in this case is 0.3. So we're looking for this value of p. So this is the p we are looking for. So this is what we need, this column. The block is n equals to 8 and the probability of success is 3. So this is the idea. But the problem is the sum that we did, that sum was x equals to 2. So the question was exactly 2. And if we go back to our table, we will see that there is no, in our block, this 2 means the 2 that we have here, this 2, it does not mean exactly 2. This 2 does not mean exactly 2 because it's a cumulative table. Again, it's a cumulative table. Cumulative table means less than or equals to. That means if I say 2, it has to be 2 or less than 2, meaning add up all the numbers from 0 up to 2. So cumulative distribution means less than or equals to. So 5 means 5 or less than 5. Add up everything up to 5. That's what it means. So we have to somehow convert that equal to 2, exactly 2, to less than or equal to 2. Only then we can look up the table. This value we can look it up. So where the block is 8, n equals to 8, the probability is 0.3 and the random variable is less than or equals to 2. So let's get back to the sum. So if we get back to the sum, so we have to devise a way of doing it. So one way of doing it is thinking about is like, if we have something like less than or equals to 2, that means 2 1 0, that it means, this is what it means, less than or equals to 2. Now if we have less than or equals to 1, it means 1 or less than 1. So now if we subtract from here this one, if we think about an area, if we subtract from this bigger area this smaller rectangle, the only thing that will be left is this 2. So we can actually write that equals to 2, we can write it as in less than or equals to, so x is less than or equals to 2, subtract x is less than or equals to 1, that will actually give us 2. So if we think of 2 as less than or equals to 2, so we get 2 1 0. If we think of 1 as less than or equals to 1, we get 1 and 0. So remove that, whatever you have left is going to be 2. So this will represent x is equals to 2. So if it was 5, it will be x is less than or equals to 5, subtract x is less than or equals to 4, and so on. So if we now go back to the table, so what is the value in the table? So x is less than or equals to 2 is 0.5518. so let's go back to the sum, 0.5518. So 0.5518, and we subtract, and we need 1 is less than or equals to. So again, let's go back to the table. So here it is going to be, this is 1 in this block, n equals to 8. This is going to be 0.2553, 0.2553. So now if we go back to the sum, so this would be 0.2553. So if we subtract the 2, we get 0.2965. So 0.2965. So that's the answer, the probability. The next one says more than 4. So if we do the next sum, it says more than 4. So more than 4. So more than 4 means it has to be greater than 4. That's what more than 4 means. It would be greater than 4. So it would be probability of x is more than 4. So more than 4 means, since this is discrete, it has to be 5. More than 4 means 5 6 7 8 and so on, but it has to be more than 4, so it is 5. So we want 5 6 and so on. So we want more than 4. Now we can take the whole thing, whole probability, and we can remove this from it. We can remove this. So from the total, if we remove 4 or less than 4, 4 3 2 1 0, we will get whatever is left, which is 5 6 and so on. So more than 4 can be written as 1 minus less than or equals to 4. So we can look up the table and we can find this out. So the same block, so we need less than or equals to 4. So less than or equals to 4 is going to be, it is going to be here, 0.9420, 0.9420. So if we get back to the sum, it is going to be 1 minus 0.9420, and we are going to get 0.058. So 0.058. We can put a 0 at the end to make it 4 decimal places. So this is a binomial distribution sum.